Dear students, welcome to mathematics online classes. In the last session, we have derived sum of first n natural numbers formula, sum of squares of first n natural numbers formula, sum of cubes of first n natural numbers formula. Using all three formulae, now we are going to solve the problems on that. Before going to the problem, I want to tell you one thing here. See, suppose nth term is known to us, nth term of a sequence is known to us, that will be represented as an is nothing but it is nth term. Using nth term, we will be calculating sum of first n terms here. Okay, Sn is nothing but here sum of first n terms, a1 plus a2 plus a3 so on up to an. Sn we will be calculating. This a1 plus a2 plus a3 so on up to an can be written as Sn is equal to summation of ak, where k varies from 1 to n. If you want sum of first 20 terms, this can be taken as summation of ak, where k varies from 1 to 20. This term we will be using in calculating, means while solving the problems on special series. Okay, I hope all of you know those three formulae which you have derived in the previous session. Now let me take the problems on this. Example 20. Example 20 I am taking now. It says example 20 is find the sum to n terms of the series, find the sum to n terms of the series whose nth term is n into n plus 3. Here nth term is directly given to us. Now we need to find the Sn, sum of first n terms we need to find. This is an is equal to n into n plus 3. An is equal to n, if it multiplies this becomes n square plus 3n. We want ak, so we will replace n by k. That can be written as ak is equal to k square plus 3k. In place of n we are writing k, that's all here. Now Sn is equal to summation of ak, where k varies from 1 to n. This is the general concept. What does it mean? If you take k equal to 1 to n values, it becomes a1 plus a2 plus a3 plus so on up to an. That is nothing but sum of first n terms. This is summation of k square plus 3k, where k varies from 1 to n. This can be written as Sn is equal to summation of k square, where k varies from 1 to n, plus summation of 3 into k, where k varies from 1 to n. Now summation of k square, where k varies from 1 to n, plus of what is this? Summation of 3k, it means 3 into 1 plus 3 into 2 plus 3 into 3 plus 3 into 4 so on up to 3 into n. In all those terms 3 is common. I can write means I can take 3 common, so we can write here 3 into summation of k, where k varies from 1 to n. 3 we can take outside the summation symbol. What is the summation of k square? Summation of k square means 1 square plus 2 square plus 3 square so on up to n square. Sum of squares of first n natural numbers it is. We know the formula n into n plus 1 into 2n plus 1 divided by 6 plus of 3 into next. What is summation of k, where k varies from 1 to n? It means 1 plus 2 plus 3 so on up to n. Sum of first n natural numbers it is. We have the formula as n into n plus 1 by 2. We need to simplify this. What is common from these two terms? N into n plus 1 by 2 is common. Take it out. N into n plus 1 by 2. Now the remaining terms, 2n plus 1 by 3 in the first term, and from the second term it is just 3. N into n plus 1 by 2 is outside. You simplify this. N into n plus 1. Here if I cross multiply, this becomes 2n plus 1, 3 into 3, 9 divided by 3. This is n into n plus 1 into 2n plus 9 is 2n plus 10 divided by 2 into 3, 6. N into n plus 1 into, here we have 2 common, into n plus 5 divided by 6. 2 ones are 2, 3s are. N into n plus 1 into n plus 5 by 3 is the Sn. This gives us sum of first n terms of series whose nth term is n into n plus 3. This is about example 20 in the NCERT textbook. Now let me take example 19. Example 19, it uses a special method to explain a problem on Sn formula. I took this example 20 first. Example 19 says, find the sum to n terms of the series, n terms of the series 5 plus 11 plus 19 plus 29 plus 41, so on. Find the sum to n terms of the series. This is a special series. You see, it is not in AP and it is not in GP. You can check it. 11 minus 5 is 6 and 19 minus 11 is 8. You see, difference is not same. It is not in AP. You can check, it is not in GP also. It is a special series. How will you solve this kind of equations? This kind of equations we will solve by the method known as method of differences. How method of differences work? Sn is equal to, our work is to find out sum of n terms, means sum of all these terms. Sn is equal to, I have here 5 plus 11 plus 19 plus 29 plus 41, so on up to the last term. Last term can be an. Okay. Now in the method of differences, what we do, we will write the same series once again just by positioning to the right, one place right. 5 plus 11 plus 19 plus 29, so on up to here an minus 1th term will be there, plus of anth term will be there. I am telling you this is method of differences. So subtract the first, subtract the second series from first. Subtraction, change the sign. Fine. Sn minus Sn, this becomes 0, which is equal to 5. I am not subtracting with anything, keep that as it is, plus of 11 minus 5, 6. Next, 19 minus 11 is 8, 29 minus 19 is 10, 41 minus 29 is 12, so on it is going like this. Here also one term will be there, last term will be minus an. Last term is not subtracting with any term here, that is separate only. You leave this first term 5, except this 5, all these terms you observe, these terms or in arithmetic progression. 2, difference between first two terms 2, difference between next two terms 2, difference between 10 and 12 2, like that it is. It is in arithmetic progression with the first term a is equal to 6 and the common difference d is equal to 8 minus 6, nothing but 2. Before applying this formula, I will rewrite this sentence. Minus an is there now, that one I will take to the left hand side. If I take an is equal to 5 plus of 6 plus 8 plus 10 plus 12 so on of 2. Here an is taken outside. How many terms will be there? An minus 1 terms will be there. You have to be careful. Nth term, last term is taken outside. In this series only 5 is completely outside, we are not including it. If we include 5 also, this will not be in arithmetic progression then, because difference here is 1. 5 ಅನ್ನು ಅದರಲ್ಲಿ ಇನ್ಕ್ಲೂಡ್ ಮಾಡುವಂಗಿಲ್ಲ. 5 ಅನ್ನು ಬಿಟ್ಟು ಉಳಿದ ಎಷ್ಟು ಟರ್ಮ್ಗಳಿದಾವಪ್ಪ ಅಂದರೆ ಇಲ್ಲಿ n ಮೈನಸ್ 1 ಟರ್ಮ್ಸ್ಗಳಿದಾವು. ನಂಬರ್ ಆಫ್ ಟರ್ಮ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು n minus 1. This is what we are getting nth term of this special series, nth term. Now to take the sum of all these, what to do? Use the formula Sn is equal to, as it is in AP, Sn formula we know, n by 2 into 2a plus n minus 1 into d. An is equal to 5 is outside, it will be as it is. I am taking the sum of all these. Number of terms are n minus 1. In place of n, I have to write n minus 1. By 2 will be as it is. 2 into first term is 6. 2 into 6 plus of n minus 1 into n is n minus 1. This minus 1 is extra, that will be kept as it is. And common difference is 2. Here also 2, here also 2. 2 you take outside. 5 plus n minus 1 by 2 into 2 I am taking outside. 6 plus n minus 1 minus 2. 2 get cancels. 5 plus n minus 1 into this is n plus 4. This is what? This is still an is equal to, nth term is equal to, we are calculating an is equal to 5 plus, I will multiply those, n into n square, n into 4, 4n minus 1 into n minus 1 into 4 minus 4. an is equal to n square, 4n minus n, 3n, 5 minus 4 is plus 1. What is this? Still it is an, nth term of this special series it is. We need ak, right? Replace k is equal to n. Ak is equal to k square plus 3k plus 1. Okay, using the Sn is equal to summation of ak, where k varies from 1 to n. This one we have summation of k square plus 3k plus 1, where k varies from 1 to n. This can be written separately like summation of k square, where k varies from 1 to n, plus 3 into summation of k, where k varies from 1 to n, plus summation of 1, where k varies from 1 to n. Summation of k square is sum of squares of first n natural numbers. We know this formula as n into n plus 1 into 2n plus 1 divided by 6 plus 3 into summation of k is sum of first n natural numbers, n into n plus 1 by 2 plus of summation of 1 is summation of 1, you should not write it as 1, this is n. Summation of 1, where k varies from 1 to n, means it is 1 plus 1 plus 1 plus 1. How many times? N times it is getting added. Summation of 1, where k varies from 1 to n, is n. If k varies from 1 to 5, then it is 1 plus 1 plus 5 times. That answer will be 5 into 1, 5. Okay, we need to simplify this. You take the common here. What is common from all three terms? N is common. Take this outside. Remaining n plus 1 into 2n plus 1 by 6 plus of n is written outside, 3 into n plus 1 by 2 plus 1. Take the LCM. LCM is 6, n plus 1 into 2n plus 1 into 2 3s are 3 into 3 9, 9 into n plus 1 plus 6. n into, I will multiply this, n into 2n, 2n square. Next n into 1, n plus 2n plus 1 plus 9n plus 9 plus 6, all divided by 6. n into 2n square plus 2n plus n, 3n, 3n plus 9n is 12n. Next 6 plus 1, 7, all divided by 6 will be there. Now we need to simplify this. Simplifying, 2n 2 into n, this is 14, product should be 14 and the sum should be how much, 12. Like that we have to choose the numbers. Sorry, here we wrote it wrong. 2n square, n plus 2n, 3n, 9n plus, that is 12n, right? 1 plus 9 plus 6 is nothing but 16. We wrote it wrong. Fine. Now we will solve. What is common among them? Common is 2 here. 2 you take common, this becomes, I will write it here. Sn is equal to n into 2 is outside. We have n square plus 6n plus 8 divided by 6. 2 ones are 2 3s. n into n square plus 6n plus 8. It is a quadratic equation. Quadratic equation we will split it. n square plus 4n plus 2n plus 8 divided by 3. n into, n is common here, n into n plus 4 plus 2 into n plus 4, all divided by 3. n into n plus 4 is common, remaining terms n plus 2 divided by 3. Therefore, Sn is equal to n into n plus 2 into n plus 4 divided by 3 is the answer. This is the method known as a method of differences. 5 plus 11 plus 19 plus 29 plus 41, so on. This is a special sequence. Method of differences in the sense we will take like this, we will subtract, and here these terms onwards, those are in arithmetic progression. Last term an will be there, an we will take to the left hand side. 5, we should not include this 5. Remaining terms are there in the arithmetic progression. Take the sum of all those, because here sum of all those is there. This gives us nth term of the special series. Nth term of the special series we got n square plus 3n plus 1. Then ak equal to k square plus 3k plus 1. Special series sum. Sn is equal to summation of ak, where k varies from 1 to n. Yes, if you go on solving like this, we will get the answer as Sn is equal to n into n plus 2 into n plus 4 by 3. Dear students, now we will go to the exercise 9.4. Exercise 9.4, find the sum to n terms of the series. Here first series is 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. Some of you saying that you don't have the textbook for the homeworks. Textbook anyhow it is freely available in Google. You download it. NCERT textbook mathematics 11th standard, like that if you type, it is freely available. PDFs are available and many apps are also available for that. You have a textbook for that. See, 1 into 2 plus 2 into 3, this is a special series. We are going to find the sum of that. Sn we are going to find. Before going to the Sn, we should know an, nth term of this. How will you get the nth term? 1 into 2, first terms you observe here. 1, 2, 3, 4. First terms of each are in arithmetic progression. And second terms 2, 3, 4, 5, these are also in arithmetic progression. Okay. Now what we will do, nth term is equal to, that is an is equal to nth term of 1, 2, 3, 4, so on, which is multiplied with nth term of 2, 3, 4, 5, so on. Multiplication is there. I am taking the nth term of this first terms 1, 2, 3, 4 like that, and into multiplied with the nth term of second one 2, 3, 4, 5 like that. An is equal to, what is this nth term? 1, 2, 3, nth term will be n only. Directly I can write. And second one you observe 2, 3, 4, 5. These are in arithmetic progression. With a is equal to 2, number of terms will be n, and common difference d is equal to 1. We will use the formula here. An is equal to a plus n minus 1 into d. Using this formula, we can write 2 plus n minus 1 into common difference is 1. Okay. N into 2 plus n minus 1. This is n into n plus 1. What is this? An is equal to n into n plus 1. This one I have. What is ak then? Ak is equal to k into k plus 1. I can write ak is equal to k square plus k. Now going to the formula, using Sn is equal to summation of ak, where k varies from 1 to n. This is summation of k square plus k, where k varies from 1 to n. Can be written as, this can be written as Sn is equal to summation of k square, where k varies from 1 to n, plus summation of k, where k varies from 1 to n. What is summation of k square? Sum of squares of first n natural numbers. That is nothing but n into n plus 1 into 2n plus 1 by 6, plus of summation of k is 1 plus 2 plus 3 up to n. That means sum of first n natural numbers. We have the formula n into n plus 1 by 2. Take common here. Common is n into n plus 1 by 2. Remaining 2n plus 1 by 3 plus 1. n into n plus 1 by 2, cross multiply 2n plus 1. If you cross multiply, this becomes 3 divided by 3. n into n plus 1 into 2n plus 4 divided by 2 into 3, 6. n into n plus 1 into 2 is common here, into n plus 2 divided by 6. 2 ones are 2 3s. We have n into n plus 1 into n plus 2 divided by 3. That is what Sn is equal to. We can cross verify this. Whether the Sn you got is correct or not, we can cross verify. How? If you substitute n is equal to 1 here, it should give us the first term. If you substitute n is equal to 2, what you should give? It should give us sum of first two terms. Let me substitute, let me check with substituting n is equal to 1. If we substitute n is equal to 1, this becomes 1 into 1 plus 1 into 1 plus 2 divided by 3 is nothing but 1 into 2 into 3 by 3. 3 3 get cancelled. What I am getting? I am getting 1 into 2. First term you see 1 into 2. Like that we can cross verify. N equal to 2 you substitute. This gives us S2, means sum of first two terms. Sum of first two terms, you check whatever we get here, and here also you take sum of first two terms. 1 into 2 plus 2 into 3, 6 plus 2, 8. Here also you should get the answer 8. Then whatever you did is correct. This is about first problem in the exercise 9.4. Now we will move on to the next, that is otherwise we will go to the time is over. So what we do in the next session, we will take the remaining problems. Homeworks, you try problem number 2, 3 and 6. 2, 3 and 6 you try. Thank you.